Hello and hello everyone and good day. In this section, we will be discuss the analysis model for particle under constant acceleration. So, if the acceleration of a particle varies in time, its motion can be complex and difficult to analyze. So, as we discussed in the previous section, uh, so we can observe that uh, if we graph if we graph our velocity time graph and acceleration time graphs, it is very complex no ang iyang curve sa iyang acceleration with varies to time, di ba? So di nato ma-predict kung unsa iyang instantaneous acceleration with that specific instant of time. Okay? So a very common and simple type no para ma-determine nato ang usa ka equation just like here or maka-came up tag general equation. So atong buhaton is to i-constant nato ang acceleration. Okay, so in such a case, the average acceleration at any instant within the interval is numerical equal to the instantaneous acceleration at any instant within the interval in the velocity changes at the same rate throughout the motion. So this situation occurs often enough that we identify it as an analysis model that the particle under constant acceleration. So as we observe in this figure, no, if we want to graph the under the constant acceleration, if we want to graph the distance time graph, so ang mahitabo sa iyang curve is may ani no, di ba? Mahimo siya og quadratic nga equation. Okay? So our degrees of curveness here is equal to or second degree no, di ba? Okay? So kung ato i-graph siya in terms of velocity time, so mahimo siya og first degree na lang or slope line. So di ba as we observe here in xt nga diagram, so at every point there is mao na yang slope or kung unsay slope there is maupod na ato ang velocity, specific velocity at with the specific of time pod no. So since our velocity time graph here is varies linearly no, that we can create some slope line from t is equals to 0. Our velocity here is initial velocity no, so our final time that is equal for velocity final. Okay, and we know that our slope nga ma-create diri sa atong line sa atong VT nga diagram, that is equal to our acceleration time graph, which is our slope here. Since this is under constant acceleration, our slope here is equal to 0. Okay, so dili mo change ang iyang acceleration with respect to time. Okay, so now if we are going to create some formulation or general or equation, came up some equation, so we can create some equation by defining the acceleration. we know that our acceleration is that is equal to the delta or the changes of velocity with respect to interval of time. Okay, since our velocity since our change of vx is equal to vx final uh, minus the velocity initial, okay, over the t final minus t initial. So mura ra siya ko ano, kung ato ni siyang i-observe, mura na siya og slope sa kaning defining the slope no sa kaning line here nga na-create for the velocity time graph. So mura siya ang kani is mura siya og 2 points slope form ba na formula. So velocity, we have here velocity f and t final. So in here is velocity initial and t initial, which is equal to 0. Okay, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Kani siyang equation. So since our t initial here is equals to 0, so may bilin na lang sa itong equation is acceleration gi-assume ni at x direction no, is equals to vx f minus vxi over t final. So kung ato siya i-cross multiply and rearrange in terms of velocity final, we have this equation that is equals to velocity initial plus ex times the time. Okay, so because velocity at constant acceleration varies linearly in time according to previous equation, so sa atong previous equation we have here no vxf equals to vxi plus ex times t. So we can express the average velocity in any time interval as the arithmetic mean of the initial velocity and the final velocity. Okay, so as we observe diri no sa kaning graph VT diagram, we can predict or we can calculate the average velocity by the means of getting the mean to sa kaning between these 2 points no. Here is mo niya to ang average velocity by averaging. So vxi here vxi plus vxf over 2. So muna to ang vx average. So recalling the equation to obtain the position of an object as a function of time. Okay, so asa na siya, this one is obtain the position of an object as a function of time. vxf minus v no, this equation no is mo niya to ang kuano formula for the average velocity that we obtain no sa pag niaging discussion. We have velocity average is equals to x final minus x initial over the entire interval of time. Okay, so create tag equation ani, then by rearranging in terms of x final, so mangyani nga equation no, so iyarang balhin ang o transpose ang xi, okay, from the other side of equation, and then x final that is equal to x initial plus, so gipagawas ra niyang 1/2, then times vxi plus vxf times the t. Okay, then we know that our vxf, so our vxf is equal to the vxi, no, plus ext, diba? So if we substitute here for this equation, so nanatay ingani ang makakimi up sa to ang equation. Okay, since this is both like terms, diba? So pwede ni siya ma-sum up, so mahimo siya 2vxi. Okay, so then gi-distribute balik ang 1/2. Since distribute naman, so ma-cancel out niya ang 2, and then ang mahibili na ng 3 is vxi, then distribute po ang ato time, so mao na nga nahimo siya t squared po diri, no? So if this condition is in a reference with the time is equals to 0, so ato ang distance ana is equal to 0, so we can cancel out for the initial nga distance. So may bili na lang is final distance, so ingani na yung ma-create sa to ang equation. So x final is equals to vxi times t plus 1/2 ex times t squared. Okay, okay, so we know that our average velocity is equals to xf minus xi over t, di ba? Okay, so if we go back here sa kaning equation, so ingani ang mahitabo, no, di ba? Kung ato i-rearrange, and then by using this equation, no, in terms of t, so mahimo siya xf minus xi over the no, this one here dili mao ang kuha na equation nga ato i-substitute diri. So atong i-substitute daay is in terms of acceleration, no, di ba? So we have acceleration man, di ba, sa definition nato is equal to vxf minus vxi over the time with minus the t initial, kung ato i-kuan in terms of 0 ang initial nato. So ngani ang mahitabo vxf minus vxi over ex ang ma-substitute sa ato ang time. Okay, then by combining this equation, so ngani ang mahitabo sa atong equation. So mahimo siya vxf squared minus vxi squared over 2ex. Okay, so nay ma-cancel out din no pag gamit na to special product. Then gi-rearrange balik, gi-transpose balik ang initial distance na to, and then in terms siya of final velocity squared. So now we have here the second equation. This one here is ang na-create na to nga equation is in terms of the relationship with with the distance, initial nga velocity, and then we have here the acceleration and the time, no? Here ang naka-difference lang between these two equation is kung wala siya time, no? So kaniya tong gamiton nga equation. If na siya time and if na siya ni siya velocity or na siya acceleration and distance, or ang gipangita ba is ang x final. So if sa given problem is na siya vxi and time and also the acceleration, so pwede ta makagamit aning equation. And for the other nga equation katong akong gi-present ganiha kani siya, no? So if wala siya distance sa given problem, so pwede ta mo gamit ani, no? If na velocity and the acceleration or the time. So these three equation is this is the tool, no? And this is the tool that we can use for solving a problem with one dimension, and it is very useful po nga gamitin for the higher nga topic, which is the in a motion in two dimension, which katong magisgo na tawag projectile or projectile nga motion. Okay, so kani silang tulo nga equation is forte yung gamita. It is powerful nga magamit jud siya sa 2D dimension. Okay, so since you have taken the subject of integration right now, so I assume na nana mo ay basic idea sa integration, no? So katong three equation nga atong na-derive earlier, we can also derive from the calculus, no? Which is the integral calculus. So in calculus, the procedure used to perform this task is referred to either as integration or as finding the antiderivative. So graphically, it is equivalent to finding the area under a curve, which is kaning figure, no? Ato siya consider that this is our curve, no? That is describing by the motion of the particle. Okay, so mathematically the velocity equals to the derivative of the position, no? With respect to this time. Okay, it is also possible to find the position of a particle that if it is velocity is known as function of time. Okay, so in calculus, the procedure used to perform this task ano siya, ang paggamit sa ato ang integration. So now, in referring this velocity time graph, no? So let us divide the time interval, which is the t final and the t initial, into many small interval, each duration that is that delta tn, where kung ato na siya i-divide, so maka-create some rectangular nga pieces, or this is what we call the strip, no? Okay, so the area of the shaded rectangle is equal to the displacement in the time interval, that is change of tn. Okay, so nganong gibuak-buak man tani or pieces by pieces na to, and in terms by rectangle. So di na to ma-analyze, no, ang some changes of displacement or the with a small infinite of changes of velocity, no? So, di nato ma-analyze kung di nato pieces by pieces. And di nato ni ma-sum up ang tanan kung di ta mo gamit by using this strip, no? So atong strip commonly nga shape ana is rectangle. Okay? Then the shaded area here is mao na to ang displacement in the time interval, which is the delta Tn. So where our change of x or our displacement here, that is equal to the limit, no? So gamit na po tag limit here, that is the change of t approaches to 0. So nganong gi approaches to 0 ni nato? So kung ato ni i-kuan pa gyud ka ng paggamyon pa gyud ang iyang rectangle, so what happened here is ma-fit gyud siya sa kaning curve nato dinhi. Okay? The more the steeper the rectangle, the more pud nga mo fit siya sa ato ang curve diri. Okay? So that's why nga ato ang change of t diri is gi approaches nato into 0. So now why is it this one is kuno velocity average? Ngano ni ani niya hang equation diri? So para makuha na to ang area under the curve in the velocity time graph. Okay, so therefore mag-sum up ta sa mga rectangle nga na-create nato under this area or under this curve, no? So unsa na to pag-sum up? So using this sign, no, which is summation, that would be our end here is from 1 to, this one is to infinity, no? N nato is approaches to infinity. Okay? So the more nga daghan ato ang strip here, kani mga strip man siya, the more pud nga mo steeper or mo gamay ato ang rectangle, no? So para ma-fit gid siya sa kaning ato ang curve, then makuha na nato ang iyang total area of this curve, that is the boundary of t initial and t final. Okay, so we have vxn, that is change of t, diba? Our velocity is change of x over change of t man. So gisum up na nato ang the whole or the total area under this curve. Okay, and this one, kaning equation is nag-define pud na siya in terms of referred to integration, no? Mo ni gitawag og definite integral. So, integration of t final from t initial to t final, which is the vxt dt, or our change of x is equal to the integration of t from t initial to t final vxt dt. So we now use the defining equation for acceleration and velocity. So to derive two of our kinematic equations, we know that our ex is equals to the dvx over dt, or the delta v over the delta t. So now, by using our integration, no, with the boundary limit we have for the velocity is vxf and Vxi, and the boundary limit for the delta t is the t final and dt initial. So now by integrating, so by integrating, so mahimo na siya ang makancel out na niya ang differential nga elemento. Mahimo na siya og velocity na lang. Then substitute sa boundary limit mahimo siya atong limit mahimo siya og Vxf minus Vxi. Di ba ang pag-substitute sa ato ang mga boundary limit is upper limit minus the lower limit, no? Also here, upper limit nato is t final, and then our lower limit is 0. May mo siya tf minus 0. So Vxf minus Vxi is equals to ext. So now we have the equation nga na came up, no? So the same as the equation nga atong na came up with before. Using the katong velocity time graph gihapon, which is under the condition of constant acceleration. For the velocity, we have velocity is equals to dx over dt, or delta x over delta t, and that we know that our dx over dt, or the final velocity man, final velocity is equal to the equation of Vxi plus ext. Okay, then by doing the integration, so integrate na to tagsa-tagsa. Okay, so after the integration, so ang may tabuan is syempre ato i-substitute ang mga boundary limit. We have upper limit minus lower limit. Also here, upper limit for the delta t, upper limit minus lower limit. And here, which is using the power rule, no, by integration, so ma-increase ang iyahang mo raise into 1, di ba? So may mo siya t squared over 2. So ato ang power our rule for the integration, no, we have t using the power rule, which is that x raised to n. Kung ato i-integrate, may mo siya x raised to n over n, di ba? So mo na yung nahitabuanin mo mo siya t squared over 2. Okay? So we could came up for the other equation no nga atong na derive before pod, which is kani. So since kung ato ang initial distance is 0, so may mo siya x final is equals to Vxi times t. This one is here is plus minus, no? It's either naka-decelerate or accelerate siya with a constant nga condition. So we could also derive the equation, no, for the last nga equation nga na derive po nato before. So using these three nga defining pag-define sa acceleration and velocity. So when dt is equals to dt, so ato ang equation po na is equal to df over dx, that is equal to dx over vx. And then by cross multiply and by using the integration na concept para ma-cancel out niyang differential element. So we know that here na may variable nga v, no? So pag integrate ang result is may mo siya v squared over 2, di ba? Then by substituting the boundary limit, so ang may tabuan ni ang equation, no? And also for the for getting the dx, no? Resulting integration of dx. So may tabuan ni mahimo siya og x final minus x initial, or ginatawag ko na siya og differential x yapon. Or kani pwede ra ninyo imo og x final kani dx imo ninyo og x final minus x initial, no? So pwede ra pod na siya. Okay. So now let's have a sample problem 1. A particle is moving along a straight line with the acceleration a is equals to 12t minus 3t raised to 1 half, where t is in seconds. So determine the velocity in the position of the particle as a function of time when t is equals to 0 and v is equals to 0 and s is equals to 15 feet. So for the solution, we could use the defining equation for the acceleration. So acceleration is equals to dv over dt man. Then by using the integration concept, so we could came up, no, for the equation of velocity, which is 60 squared. So anong nahimo na siya 60 squared? I think this one here is 12t day, no? 12t. So nasayap lang. So mahimo siya og 12t squared over 2. So then ma-cancel out, ma-reduce into ang kaning 12 ma-reduce into 6. So mahimo siya og 60 squared minus, so increasing by 1 ang raised diri to variable of t. So may mo siya og 1 half plus 1 may mo siya og 3 halves. So over 3t raised to 3 halves over 3 halves. So makancel ang 3. So may bilin na lang reciprocal ang 2. So may bilin na lang is 2. So may mo siya og 60 squared minus 2t raised to 3 halves plus c. So we know that our t is equals to 0 and v is equals to 0. So we could conclude that our c is equals to 0 gyapon. So now our equation here for defining the velocity is mo na lang ni siya, no? V is equals to 60 squared minus 2t raised to 3 halves. So kanay makancel out na ni siya. 0 naman na siya. Wala na butang lang ang final nga equation, no? But ang atong equation is for the velocity is 60 squared minus 2t raised to 3 halves. Okay? And also for the position of the particle, no? We know that our velocity is equals to ds over dt, di ba? Then by using the integration and using this equation nga na-generate na to for the velocity, so by substituting, you know, for the velocity, no? So velocity, di ba, velocity is equals to ds over dt. Then ato siya ibalhin diri, so pwede siya ma-integrate in terms of t. Then here is in terms of s. So now resulting integration is ato siya i-substitute ang boundary limit, no, which is s, then minus 15 lower limit minus upper limit is equal to 60 cube over 3 minus 40 5 halves over 5. So gipang increase lang ang mga exponent here. So 2 plus 1, which is 3 over 3. Then 3 halves plus 1 is equals to 5 halves over the 5 halves. So ang to diri na reciprocal, diri na imo 4. Then we can reduce sa dani, no? 6 over 3. Mahimo na lang siya og ko siya na-reduce. Pero ang iyang final nga equation ani is s is equals to 2t raised to 3 minus 4/5 t raised to 5 halves plus 15. Okay? For sample problem number 2, an elevator descends from rest with an acceleration of 5 feet per second squared until it achieves a velocity of 15 feet per second. To determine the time required and the distance traveled. So solution for here. So we can use the equation that we have derived before. So sa tong equation, since our gipangita diri is the time and distance, no? So ako lang nauna ang distance pagkuha. Pwede ta magagamit ani nga kani nga equation. V squared is V final squared minus V initial squared plus 2 times acceleration times dy or yf minus y1. So atong y1 or yi in terms na lang nato 0, no? So now we know that we have kuan naman, di ba? 15 feet per second, no? Na final velocity. So atong initial velocity, since niingon man siya sa problem nga from rest daw no ang ato ang elevator, no, sa pag-descend. So our initial time our initial nga velocity with respect to initial time is mo equal to 0 na siya, di ba? Then ingon siya until it achieves a velocity of 15 feet per second. So this one here kani nga value is mo ni ato ang final nga velocity. Okay? So that's why nga na-cancel out ang velocity yi squared here, di ba? So ang may bili na lang is 15 squared is equals to 2 times 15 times dy or y final lang. Okay? So our final distance is equal to 7.5 feet. Now for the time, we have the distance naman, di ba? Final distance na napud tay acceleration and na napud tay velocity, final velocity. Diri nga equation wa man siya nagamit og kuan for the final velocity. So but ingon man siya nga sa tong problem is ni rest daw. So kani makancel out na niya ang velocity yi times t. So makancel out into 0, no? Here pod gi-assume nato from rest ang iyang reference distance na is equal to 0. So we could cancel out pod diri. Now our yf is equals to 7.5 feet man, di ba? And then our acceleration is 5 feet per second squared. Now may terms na siya og one variable which is the time, no? So our time kung ato na i-calculate, so let me check if sakto ba. 7.5 is equal to 5 times t alpha x squared over 2. Shift solve equals, that is 1.73 seconds. So that's all for the acceleration with under the condition of constant acceleration. So in the next chapter that we will be discuss is you can advance study, no, for motion in 2 dimension. So mo na to i-discuss for the next chapter. So thank you for your listening and have a nice day.